to educator.com. This lesson is about test-taking strategies, and we are on part 4. Eliminating the answer is a very important test-taking strategy. You should always begin by eliminating answers that don't make sense. This can help you focus on fewer possibilities. If you will need to make an educated guess, you have a better chance of choosing the correct answer because you've eliminated answers that are wrong for sure. Let's try this example. In an election, the winning candidate received about 86% of the votes. If 568 students voted, how many voted for the winning candidate? Now, suppose you were not sure how to find the percent of a number. You should, however, understand that 86% is most of the students. So we would take out 380 because that is very nearly half of the students, or just a little bit more than half. So we wouldn't want 86%. And then 510 is most of the students. So that might be around 90% range. So I could also take out D. So now I'm down to 2 answers. And if you didn't know how to find a percent, your chances of guessing the correct answer are a lot better. But let's say that we do know how to find percent. 0.86 times 568. 6 times 8 is 48. And at that point, your last number 8 has shown up in answer C. You could stop at that point and you know your answer would be C. Let's continue just to make sure that we get the answer correct. 36 plus 4 is 40, and that's 34. Hold the place, and that's 64. 6, 48. 48 plus 6 is 54. And that's 45. So it's 488.48. So it's a good thing that we continue through to the problem because this 8 did not represent the last 8 here. But if I have the answer 488.48 compared to 454 and 488, it's obvious that my answer is C. So sometimes you may not want to jump the gun and choose the answer without carrying through the equation. But what we want to look at here is the fact that you were able to eliminate A and D really increased your chances of making an educated guess and guessing the right answer. A football kicker made 21 field goal attempts in one season and was successful about 73% of the time. How many goals did he make? Often percent questions can be difficult for us, but if you understand the concept behind percent, that can really help. So say you work with percents very often in school and with grades. So say you had a test with 21 questions and you got 73%. That means that you passed the test, but you maybe didn't do the best, but you got most of the answers. So let's look at which answers wouldn't make sense. Well, 5 wouldn't make sense because if you only got 5 questions right out of 21, that would mean that you did very poorly. So that wouldn't work. And in the same idea, if you got 20 questions correct out of 21, that would mean that you did very well in A. So that also wouldn't work for the 73%. So we can take out A and D. So now you're down to 2 answers, 15 or 12. So I'm going to take 0.73 and multiply with 21. We get 3, 7, hold the place, 6, and 14. 3, 13, 5, and 1, and 2. So 15.33, and we see that that will go with choice B. So by eliminating the 2 answers, I've already increased my chance of guessing between these 2 to 50%. Whereas originally, if I had to guess from all 4, I would only get a 25% chance of getting the question right. Which percent is closest to 79 over 643? Well, 79 is about 80, and I could round 643 to about 640. And then that would be easy. It would be about 1 out of, close to 1 out of 10, not quite. Well, that means that I can definitely take out 33% because 8 is not close. 8 to 33% of 64. If I did 8 times 3, that would only get me to 24. 20% means that if I did 80 times 5, that gets me to 400. Well, that's pretty close. So maybe at the most that I can estimate there would only be to take out D. So now let's try and actually find the percentage. So what I would be doing is 79 divided by 643. It doesn't go in, of course, so we're going to put a decimal, and it'll go in once here. Well, now that I know that the first number is going to be 1, I can go here and cross out C, because the first percentage here was a 2, not a 1. Now let's put in 643. 10 minus 3 is 7, borrowed, so 8 minus 4 is 4, and 7 minus 6 is 1. So now let's put another 0, bring it down, and that will be about maybe 2 or even 3. But here's what we want to think about. If I know that it's going to be 2 or 3 here, let's look back to our answers. Which one do we know for sure it's not going to be? The 10%, because 10% is not enough. We know that 643 will go into 1,470 times more than 0 times for sure. So now I can cross out A, and without having to finish this very long, complicated division problem, I know that my answer is going to be B. So at each step of the way, you can look back to your answers and see if there's another answer that you can cross out. By process of elimination, you can save yourself a lot of energy and time. Next, let's look to the strategy about answering the question asked. Carefully read the question and eliminate answer choices that are not even related to the question. That means you need to read the question very carefully, because the test writers are designed to create answers that are trick answers. Remember to reread the question and make sure you have answered it correctly. You have $10 to spend at the arcade. You buy a drink for $1.25. Each game you play costs 50 cents. Which inequality represents the greatest number of games you can play? This is an interesting example. This may not jump out at you, but there is one word in this question that will help us to cancel out 2 of the answers. It says, which inequality? Now, just that word alone will help me to cancel out 2 questions. B will be canceled out because that's an equation. And D, although is unequal, does not tell me the greatest number of games I can play. It just says that they won't be equal. So that could be the least amount or the greatest amount. It doesn't really give me the greatest amount of information. So I'm going to also cancel out D. So at this point, I have A and C to work between. So if I know that I have $10 to spend at the arcade, the most I can spend is $10. I can't spend any more than $10. I don't have any extra money. So if the very most is 10, this is the inequality that will work, A. So let's take a look at this problem. The answers look very complicated. However, just by reading the question very carefully and looking at the word choice, I was able to find the correct answer. So sometimes you need to think about looking at the words instead of being overwhelmed by the difficulty of the way the answers look. A customer buys a 3-pound cheese for $17.97. At that rate, what is the cost of a 2-pound cheese? Well, here we're estimating, probably would be our best choice, 3 pounds for about $18. So let's see which answers definitely don't make sense. So if I do 18 divided by 3, that's about 6 for 1 ounce. So here's a trick answer, this $5.99. If you read very carefully, you see that they're asking for 2 pounds. Well, if 3 pounds cost $17.97, of course it's not going to be the same cost for 2 pounds. So I can get rid of D. And now I'm basically down to B and C. Well, if 1 pound costs $6, approximately 2 pounds would be 6 plus 6, which is close to 12. And my only answer left close to 12 would be C. So by reading the problem carefully and noting that this is 2 pounds of cheese, I knew that A was not going to work. And then, very obvious, if 3 pounds cost $17.97, of course I can take out $17.97 because we're looking for 2 pounds, which should be less. So by reading the problem very carefully and reading it over again and thinking about what the problem was asking for, I was able to take out 2 answers. Now this is a type of question that you will often see on multiple choice questions. And although they capitalize the word not, you still need to be very careful and go back and think about the question because we are programmed to always pick the correct answer. And in this case, the question is asking us to pick the incorrect answer. So even though we're aware that it says not and the word has been capitalized, oftentimes we're going to go and want to pick the correct answer. So it says which number is not a solution to the inequality? 6x minus 13 is less than 11. Well, first I need to do a little bit of solving here. I'm going to add 13 to both sides. And 6x is less than 24. And divide by 6. And x is less than 24. X is less than 4. So right away I think that this should be less than or equal to. So right away I see the number 6, and I know that if x were 6, it would not be less than or equal to 4. So that's the wrong answer. And maybe you want to think that you're looking for the correct answer, and you see 4. And you think, oh, 4 is the correct answer. 4 is less than or equal to 4. But then look at the other answers. Negative 4 is also less than 4, and negative 6 is less than 4. So here we have 3 correct answers and only one that is not going to be correct. And the only one that is not correct is A, 6. So this one, you don't want to go through too quickly because you may go in auto mode and choose the correct answer because that's what you've been used to doing for the entire test. So although the word problem makes it look very obvious by making the word not in capital letters, you need to carefully think about when you're choosing your answers that you're still answering the question. This test-taking strategy is about drawing a diagram. It is often helpful to draw a diagram or a picture. If there are different objects, characters, measurements, or directions, drawing a diagram can really help you organize the information. As you'll see from these next examples, the word problems are quite long and offer us several sets of different information. So it's very helpful to draw the diagram to help us clarify the information and see how to set up our equations. Let's start with this first example. 3 glass globes, yellow, red, and blue, are placed in that order in a rectangular box. The distance between red and blue is twice the distance between yellow and blue. The distance between yellow and blue is 3 inches more than the distance between red and blue. Find the distance between red and blue. All right, so after reading that, the information seems very jumbled and maybe difficult to understand. So let's start drawing our diagram. We have yellow, red, and blue. So I might not have spaced them out accurately, but at least we know that they are in this order, and we can start filling in the information. The distance between red and blue is twice the distance between red and blue is twice the distance between yellow and red. So if I say yellow to red is represented by x, the distance from red to blue is 2x because it's twice the distance. The distance between yellow and blue is 3 inches more than the distance between red and blue. So if I were to say that the distance between red and blue is x, I would say that the distance from yellow to blue is x plus 3. So let's do a quick read over to make sure that we've gotten everything right in our diagrams before we start solving. The 3 glass globes, yellow, red, and blue, are placed in that order in a rectangular box. Okay, so in that order, yellow, red, and blue. The distance between red and blue is twice the distance between yellow and red. So we have 2x compared to x. The distance between yellow and blue, the total is 3 inches more than the distance between red and blue. So I'm going to call this a different variable because this is a different set of information. We shouldn't use y because that looks like yellow. Let's say t. I could have used d for distance. Find the distance between red and blue. Okay, so we've set up this equation. It could be, so we see from red to blue, this is also the same thing as 2x. Then using that piece of information to come down to here, it's going to be 2x plus 3. So we've combined this second set of information to compare to this first set of information. So what we're basically saying is 2x plus 3 is going to equal, this whole distance is going to equal this whole distance, 3x. So now let's go ahead and solve it. I'm going to subtract 2x from both sides, and 3 equals x, so x equals 3. So my correct answer is 3 inches. So in this problem, we were given several different objects and two very different sets of information. And by drawing this diagram, I was able to organize the information and create an equation to solve. Jenny's house, Kelly's house, and Lou's house, L, are all located along a straight road in that order. So I'm going to write Jenny, Kelly, and Lou along a straight road. The distance from K to L is 4 times the distance from J to K. So if the distance from J to K is x, then to make it 4 times from K to L, I'm going to say 4x. The distance from J to L is 36 more than 3 times the distance from J to K. All right, so from J to L, it's 36 more than 3 times the distance from J to K. So from J to K, we've already said that it's x. So if we say 3x, we're going to add 36. Let's recap and make sure that we've filled in our information correctly. Jenny's house, Kelly's house, and Lou's house are located along a straight road in that order. Let's check our order. J, K, and L. Yes, that's correct. The distance from K to L is 4 times the distance from J to K. 4 times J to K. So far, so good. The distance from J to L, the whole way, J to L, is 36 more than 3 times the distance from J to K. So if you take 3 times J to K, which is x, and make that 3x and add 36, you should get the whole distance. So now we know the whole top distance is 5x, and the whole bottom distance, which represents the same distance, is 3x plus 36. So we had two different sets of information, and we used the same variable so that we could set the equations equal to each other. Now I'm going to subtract 3x, and I get 2x equals 36. Divide by 2, and x equals 18. And there's our answer, 18 meters. With these problems, you want to give yourself time to reread the problem several times and to set up the diagram. And then make sure you go back and check the diagram. You may have to reread the information again several times. Lucy and Jennifer climbed different hills. Jennifer climbed 28 feet less than twice the height Lucy climbed. They climbed a total of 95 feet. How far did each person climb? Well, in this case, I'm going to create my characters and what they're going to equal. So Lucy and Jennifer. If I say that Lucy is represented by L, I'm going to try to define Jennifer in terms of L. It says that Jennifer climbed 28 feet less than twice the height Lucy. So if I say twice Lucy minus 28, that will give me Jennifer. And then it tells me that the total is 95. So total meaning adding the two of them together. So I'm going to take Lucy, L, and add it with Jennifer. 2L minus 28. So here's Jennifer, and here's Lucy. And together, they equal 95. So I've created an equation with one variable, and I can begin to solve. L plus 2L is 3L minus 28 equals 95. We're now down to a two-step equation. I'm going to add 28 to both sides, and 3L equals 8 plus 5 is 13, and 12. 123, and I'm going to take 123 and divide by 3. Goes in 4, 0, bring down the 3, 1, 41. So L equals 41. Now it's very careful to go back and read your problem and think about what L equals. L equals Lucy at 41. But we haven't figured out Jennifer. Jennifer is 2L, 41 times 2, which is 82, minus the 28. 12 minus 8 is 4. We borrowed. 7 minus 2 is 5. So Jennifer is at 54 feet. Now let's look to our answers and see which one worked. Lucy at 41, yes, and Jennifer at 54. Perfect. It's our answer A. So with this one, although we did not draw a diagram, it was very important for us to set up Lucy and Jennifer and clearly define using one variable what they were equal to so that we could solve the equation with one variable. Thank you for watching educator.com.